Hello everyone, today I got a video for you about the properties of logarithmic functions, or logs for short. I hope you like this mustache I made. It's so fancy like. Okay, so let's start. I'm first going to talk about the log notation, then we'll move on to the three properties or rules, of logarithmic functions or logarithms, and we are going to probably do a couple of examples, but I'm not sure if I'm going to do a two-part video. We'll see where the timing takes us. Okay, so the basic log function looks like this. It's a log base x equals y. Okay? Now, before I begin to explain, I want you to think about something. I want you to keep something in mind. Let's go back to the exponential function. If you remember, hopefully you do, the formation or the notation of the exponential function looks basically like this, right? That's how it really looks. You got the base, the exponent, and the answer, or the y, and now, keep that in mind. I'm trying to organize my ideas. Keep this in mind. We are going to get back to this. Alright? Jesus. Now, I want to explain to you that the log function can be written as in exponential form. It is much prettier and a whole lot easier to work with when it's in exponential form. But keep in mind that the examples we'll be doing, they will require you to simplify in log form. But just for the courtesy of my explanation, I want to change this to exponential form. But how do you do that? This is in exponential form. How do I take something like this and change it to, a base, an exponent, and an answer? How do I do that? How do I set it up, first of all? And what does each of these pieces, what do they mean? Well, this is what I will explain to you. Let's use the blue. So the B right here is your base. Okay? Your base of your exponent. Alright? The Y, I know you might be thinking, well, it's your answer, right? It's equals y equals the answer. It's actually not. It's your exponent. Don't worry, it will make sense to when I conclude to a statement. And the x right here is your answer. Okay, so this is new, I know, but just remember this. This is something that is crucial to know about logs. Now, let's put it all together. Let's put it as an exponential, not a function, but, in exponential form. Just get back to y. Okay, so the base we said is the b, the exponent is the y, and the answer is the x. Okay, great. This right here, this messy thing, is the same thing as this. Alright, we didn't change anything. We just wrote it in exponential form. Okay, so these things are equal. Yeah, they mean the same thing. If you graph this and graph this, you will get the same graph. Okay, now remember how I said keep this exponential function in mind? Now is the time when we actually need it. And oh jeez, come on. Oh, okay, I want to do a comparison. What is different? Oops. What is the difference between this? Between this function and this function? How do they differentiate? Well, let's see. The base, well, they remain. We still have the base here and the base there because it's an exponential form. However, you see that the y here is the exponent, where the y here is your answer. The x here is your answer, where the x on this side is your exponent. So okay, hopefully you might come to a conclusion, but I'm going to tell you what this means. This is called an inverse. When you switch, recall that finding an inverse, hopefully you know inverses, finding an inverse requires to switch your x and y's. That's your basic rule. Your first and foremost rule is to switch your x and y's. And it's really simple. And that's what we are doing here. That is happening are your x and y's are switched. That's all. The b is there. This is not a p now. It's still a y. It's just switched. You know, the variables are the same, so it's easy to understand. This means that the logarithm is the inverse of the exponential. Okay? So now that we know that, let's start with the properties, because this is the notation. This is it. This is in log form. This is the same thing but in exponential form. Okay? Now let's start with the 3 log. Why am I writing in capital? Properties. Alright. Number 1. If you have a log base m n, where these are two things being multiplied together under the same base, this is the same thing as writing log base b of one of these things, because this is a two-piece kind of function. So you're splitting it up. You're taking one of the things, which is the m, plus the other. You have to add it. When you're multiplying, if you want to open it up, you add the two separate pieces. Okay? So that's how, I don't like how I wrote that. And the b remains the same number. So if this was a 5, this would be a 5, and this would be a 5. There you go. Multiply two things, add them separately with the same base. Okay? The second rule. If you have the log base b over m over n, so two things dividing each other, you know, in a fraction, this is the same thing as taking the log b, same number again, of the first piece and subtracting log b from the second piece. Okay? So it's not that hard, especially when we jump into examples. It will catch on right away. And the last rule is this. If you have a log base b, and I'm going to pick one variable from either m or n because I only need one. I'm going to pick an m. Raised to a p, an exponent, any number, what the rule requires to do is to take this p and bring it down in front of the log. You want to bring down your exponent. That's a rule for logarithmic functions, okay? And don't bring the p down here beside the m, all the way behind the log. So it will look like this. B m. Oops. Alright? And that's all. These are the 3 rules. Alright? So let's quickly, you know what, I'll do the examples now actually. Let's quickly jump into our examples. So example 1. We got log, what should I do? 5, maybe 25x. Okay? So we got two pieces right here. We got a 25 and an x. They are separate. We want to separate them. Well, we want to separate them. They're not really separate now. But they are in two individual things, okay? So to separate them, to simplify it, remember, two things being multiplied together, the same thing, is taking each piece with the same log and adding them. So log base 5 of 25, so we're really doing that, you know, of 25 plus log base 5 of the x. Okay, I hope that made sense. And so you have to look at what you are doing. As you are simplifying, you have to see if you can simplify even more. Look at your two pieces. If you have a base and a number, usually you are able to solve it. Right now you are asking, if we just look at this. The question here is, what is this base, the 5, raised to in order to get 25? Because this is the b, this is the x, and the answer, the y, will be your exponent. Do you see what I just did? Okay, so we are basically solving. And I think it's fairly simple to do this. The answer is going to be 2. Okay, actually I'll erase. No, I'll leave it. It's going to be 2. So we solve this whole thing. It's just 2. You're looking for the exponent. Your answer is the exponent. Plus, well, you can't really do anything here, right? So we just copy that. And this would be your final answer, your simplified answer. Great, let's move on to example 2. Okay, sorry, it's my table. If I do a log 27 x squared, this squared is only applied to the x, okay? Alright, so again, we got two pieces, but we also have a exponent. But remember, I want to tell you something. When you are simplifying, take care of your first and your second rule first. Okay? And then, near the end, you want to apply your exponent rule. Bring the exponent down, okay? So, if we got two things multiplying together, the x squared and the 27, what do? Well, we take each piece and add it together, right? So we do log base 3 of the 27 plus log base 3 x squared. Great. Okay. Now we have an exponent here. We can bring that down, right? Remember our rule? We have an exponent, an individual, constant or whatever, or a variable. We can bring that down. Okay? So let's do that. And as we are doing that, well, look, we can do this. Log base 3, 27. What is 3 raised to get 27? Well, it's a 3. 3 cubed, or 3 to the third power, is 27. So to this, the answer is a 3, so we are, multitasking. And as we solve this, we can bring the 2 down right now. We're going to get 2 log base 3 x. I just put it in brackets. And we can't do anything here now. This is all we can conclude to. Well, it's really bad. But Yeah, that's okay. Alright, and let's do one more example. I'll do a little bit different one. I don't want this video to be too long. Probably is. Okay. So let's do log base 5 root x over 125. Okay. Alright, so we got a fraction here, right? Remember, a fraction dividing two things, the same thing as taking one piece with the log and subtracting it the other. Right? So this is the same thing as taking the log base 5 root x, one of the pieces, subtracting log base 5 125. Okay, there's a number of things we can do, we need to do actually, but I'm going to stick with this one for now. I'll analyze this piece in a minute. I'm just going to copy it. Alright, so we got a base and we got a number. Let's see if we can solve it. So, to set it up, see, I'm switching it to exponential form. 5 raised to what exponent equals 125? Well, 5 cubed is 125. So 3 cubed to the third power. 3 is our answer. Okay? And now let's take care of this. Okay, having a root is not recommended. You want to get rid of it. And if you know your root, rewriting roots and all that, I will do a brief little lesson here. The square root of x is the same thing as x raised to the 1/2 power. Well, you might be thinking, well, where in the world did you get 1/2? The goal, first of all, is to get rid of this root. Rewrite it as an exponent. Okay? So how did I get 1/2? Why isn't it 60? Why isn't it 20? Well, the rule of rewriting it as an exponent is whatever the base is, power divided by the root. So let's see if we do it. Let's do it. So the power is what x is raised to. Well, x is just raised to the first power, right? So our power is 1. 1 divided by the root. This is a second root, correct? If there was a 3 here, then that's the cube root, so it would be a 3. The root is 3. But because there's nothing, we automatically know it's a second root. So x to 1 over 2. That's how I got my 1/2. Okay? And I'm just going to rewrite the root x to the 1/2 power. So log 5 x to the 1/2 minus 3. And look at this. We got an exponent. Since there's nothing else to do, usually you want to leave this step till the end. So we can bring this 1/2 in front. And there we go. This is all we can do. That's a lot that we did. So there are 3 examples that I did. I'm going to stop it here. And I will do more in my next videos. Hopefully you understand the log properties. There's just 3 of them. Remember to take care of your first two, and then move on to your third one. Hopefully you got the log notation. You just need to practice, and I will help you with that. I'll see you in my next video. Thanks.